Hello, everybody. It is Mrs. Wilson, and tonight I'm going to talk to you about adding and subtracting mixed numbers. So, the thing with mixed numbers is you have to know what a mixed number is to start. A mixed number has a whole and it has a fraction. So, we've got a couple of examples here, like 3 3/8 and 1 5/6. They have both a whole number, the 3 and the 1, and also a fractional part, like a 3/8 and a 5/6. So, a mixed number has a whole and a fraction. Also, when you're talking about adding and subtracting mixed numbers, you know that you have to have a common denominator. So just like when you had to add or subtract fractions, you have to have a common denominator here. So we're going to do a couple of example problems, and you'll see a lot of similarities when it comes to adding mixed numbers as we did when it comes to adding regular fractions. Same thing with subtraction. They're very, very similar. So the first thing that I recognize here is I do not have I do not have common denominators. So I need to figure out how I can come up with a common denominator here. So I know that my denominator is 8 and 6. If I count by 8s, 8, 16, 24, 32, 40. And if I count by 6, 6, 12, 18, 24. And I can notice that I have 24s in both of them. So first thing I'm going to do is I'm going to try to come up with, just looking at my fractions here, I'm going to come up with equivalent fractions for 3/8 and 5/6. So 3/8 times something over something is going to give me, we knew that 24 is our least common multiple. Then we have 5/6 times something over something is going to give me something over 24. So just like we did before, I'm going to try to come up with my missing part. So 8 times 3 gives me 24. And you know whatever you write on the bottom, you write on the top. Because this fraction, 3/3, whatever is here, whatever you're multiplying by, has to be equal to 1. 3 times 3 is 9. So my new equivalent fraction for 3/8 is 9/24. Now let's do the same thing for 5/6. 6 times 4 gets me 24. Whatever I write on the bottom, I have to write on the top because we want this equal to 1 whole. 5 times 4 is now 20. So now I can plug in my new equivalent fractions for what I have over here. So I'm going to rewrite my whole problem. 3 and, now plug in my new fraction, 9/24 plus 1 and 20/24. Just like we're adding regular numbers, we're going to start over here with our smallest place. So 9/24 plus 20/24 is actually 29/24. Should be saying something to ourselves here. But let's add our whole numbers. 3 plus 1 is 4. So we get 4 and 29/24. Now you know this is an improper fraction. So we've got to do something with this. So what we're going to do is we're going to reduce it. And if you remember, this line right here means divided by. So this really means 29 divided by 24. So let's go ahead and divide that out. 29 divided by 24. And we know that 24 goes into 29 once, which gives you 24. When I subtract, I get 5. 5 less than 24, that's good. That's my remainder. So now when I rewrite this, I can rewrite this as 1, went in one whole time, with 5 left over out of 24. So we just figured out that these are equal to each other. So now I've got to kind of plug this back in. So this is the only real new part for adding mixed numbers. So I'm actually going to slide this over to here. And we had the 4. So the 4 is coming from this 4 right here. And instead of 29/24, we're going to write what it's equivalent to, which is 1 and 5/24. So plus 1 and 5/24, which should equal 1 plus 4 is 5. So 5 and 5/24. So that is my final answer here. Okay. Now what I do want to do, let me just grab a couple pens here. I wanted to show you this in picture form actually. So now I'm going to kind of go back to my original problem. So 3 and 3/8 plus 1 and 5/6. I know quite often I've said, if you get stuck, you need to draw yourself a picture. So in this case, we have, I'm just going to make little boxes. These are holes here. Okay, so we've got 3 holes, representing those 3 holes. And then we've got to have 3/8. So if my holes are the same size, I'm going to make these into eighths. So you can see we have eighths here, and I'm just going to shade 3 of them. Good. So I'm going to do the same thing for my 1 5/6. So I'm going to go like this. Here's 1. There's 1. And 5/6. So I'm going to make this into 6, just like this. And it's 5/6. So I kind of can have an idea for an estimate here of what I'm looking at. I'm looking at 1, 2, 3, 4 holes. Oh, I'm sorry. It's supposed to be, yeah, I guess I could do this. This is 1, 2, 3, 4 holes. Plus, and then you're left with your fraction. So your fraction here was 5/6, which we figured out from our work up here, which you know how to do, is 20/24. And the same thing here. We have 3/8, which is equal to, our work up here told us that was 9/24. So we could add those together and get 29/24. And then you know how to divide that out. You end up with 4 plus 1 5/4, 24th, I'm sorry, which equals 5 5/24. So picture form works or straight up math works. No worries. Okay? Either way, whatever way is easier for you. So that's an addition problem. So let's go ahead and do a subtraction problem now. So we've got 3 4/5 minus 1 2/3. So again, I'm saying to myself, I don't have common denominator, so I've got to be working with common denominator here. I know I can count by 5s, 5, 10, 15, 20, and I can count by 3s, 3, 6, 9, 12, 15. And I see 15 is my first common multiple. So I'm going to work with my fraction. 4/5 times something over something is going to give me something over 15. 1/3 times something over something is going to give me something over 15. I can fill these in. Again, whatever you multiply on the bottom by, you can multiply on the top by. And we can have this. So we figure out 4/5 is equal to 12/15, and 1/3 is equal to 5/15. So that's good. So now what we're going to do is we're going to plug these back in. So I'm just going to slide. I'm going to keep writing over here. So 3 and, instead of 4/5, we're going to write 12/15 minus 2 is our whole number. And instead of 1/3, we're going to write 5/15. So this is good. This is a nice one to subtract. So when I go ahead and subtract, I can say 12/15 minus 5/15. Remember, this is like 12 bananas minus 5 bananas is 7 bananas. Denominators don't change. And 3 minus 2 is 1. So that one's pretty straightforward. Okay, nothing too crazy there. I'm going to make one up right now because I want to show you one where you have to borrow. So let's do 2 1/2 minus 1 3/4. Sorry, you can't see that. So there we go. So I'm going to do this 2 ways. First way is I'm going to draw a picture. So I'm going to take, by starting with 2, there's 2, and then I have a half. So I'm going to shade this in. There's 1, there's 2, and then we're going to have a half. Okay? Now, in this problem, we're taking away 1 3/4. So I'm going to take away 1, but I don't have 3/4 here. So we can go ahead and we can break these up to make these be out of fourths. So I know if I go like this is now out of fourths. This is just showing that 1/2 is equal to 2/4. But I need to take away 3/4. So I've got to actually break this one up too. So there we go. So now I can take away 3/4. I already took my 1 away. Now I'm going to take away 3/4. So there's 1, 2, 3. So I got to see what's left. And this right here is all I have left. So I've got 1 piece, 2 pieces, 3 pieces. So all I'm left with is 3/4. That's all I have left. So now let's go ahead and let's prove this with the subtraction part of it. So if I have 2.5 minus 1 3/4, I know I have to have common denominators. And we just showed, and you should be able to see this pretty easily, that 2.5 is equal to 2 2/4. So I'm going to kind of skip the common denominator part of that because you should know a half is equal to 2/4. So now I'm going to take away 1 3/4. Well, you can't do 2/4 minus 3/4. You can't do 2 bananas minus 3 bananas. So you have to borrow or have to regroup. So I'm going to take away from my 2 wholes. I'm going to trade it in, which means I'm left with 1 whole. And I know that 1 whole is equal to 4/4, right? 1 whole. So instead of 1 whole being over here, I just borrowed it and brought it over here. Kind of like when you're doing subtraction, you steal from the place to the left and then you have 10. Same way. So now I really have 6/4. Well, now I can subtract. 6/4 minus 3/4 is 3/4, and then 1 minus 1 is 0. So my final answer is 3/4. Just like, that's a bad arrow, just like our picture showed us, right? So again, picture form, draw your holes, cross them out, draw your parts, cross them out, or mathematical form, okay? When you borrow, you're borrowing whatever your denominator is worth. So if you're borrowing 1 whole and your denominator here is 4, you're going to borrow 4/4. Just the same if this was my problem. Let me do one more. If this was like 3 1/5 minus, just for the sake of ease, like this, I would say, okay, I'm going to borrow from here. And then I would add 5/5 to it. So I would have 6/5. So 6/5 minus 3/5 would be 3/5. 2 minus 2 would be 0. Okay? And you can always do your check by adding them back up. You probably should do your check by adding them back up. Alrighty, so that was adding and subtracting mixed numbers. Good luck.